All right, part two. Okay, so in the last part, the last thing we ended was the making of ATP and NADPH. Okay, so that part, the light reactions are the energy capture reactions. Okay, so now I have ATP, I have NADPH, two high-powered energy molecules that I can use to do things with. Okay, so ATP and ATP produce during the light reactions. Um, okay, in the carbon reactions, this energy is used to break up CO2 and build molecules of sugar. Okay, so now we're looking at the carbon cycle. Okay, so here the carbon reactions. Okay, so okay, so ATP and ATP power the Calvin cycle. This is the Calvin cycle, which assembles CO2 molecules into carbohydrates. Okay, the first reactant is called Rubisco. So Rubisco is literally the most common enzyme on Earth. Okay, so CO2 is captured by Rubisco. Okay, so these, okay, carbon fixation. The first part is carbon fixation. Okay, fix means to add to. So I'm taking CO2 and fixing it to Rubisco. Okay, and then I'm spinning it through this cycle here. Okay, I take, I use it to make pGal. pGal is so I take three carbons, I turn it into one. Ultimately, I take three carbons and turn it into one pGal, which is one 3-carbon molecule. Okay. 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 This 3-carbon molecule, I will take two of these. 2 times 3 is 6, and we'll make a 6-carbon molecule, which I will turn into sugar. Okay, so every time I spin this around twice, I come up with two pGals. Two pGals eventually make one sugar. Okay, and so the rest of it is just remaking RUBP. Okay, RUBP is going to be needed to make this cycle again. So I'm adding 3 carbons here, I'm pulling 3 carbons out here, and in this whole process, all I do is recycle it. Okay, so these things make sugar, and then I regenerate it, and that's it. Okay. Okay, so plants use sugar for many things. Okay, so I can take sugar and use it for energy. I can use it to store energy, and I can use it to make cellulose. Okay, and I can use the energy from sucrose to make other proteins and fats that I need. Okay, so make sure you understand the slide here. Okay, and what's going on. Okay. So the plant cell uses the ATP, it produces certain light reactions to field carbon reactions. Okay. So here. Okay, let's go back. Okay. There we go. Okay. I use my ATP and my NADPH here. Okay. And my ATP here. Okay. These things, right? I'm using ATP. Okay. The ATP I got from earlier reactions, I'm using it here to fuel these reactions. Okay. So from the light cycle, I generate ATP, I generate NADPH, right? I generate ATP. And I'm using them all here to make carbon dioxide and pGal. Okay, so I'm using up all the energy I stored up earlier in the light reaction to trigger the Calvin cycle or the carbon cycle. Okay. Okay. So plants use carbon fixation pathways. Okay. Okay. So what we've been studying is something called P3 photosynthesis. Okay, which is most often used by most plant species. Okay. The importance of C3 is that it's the easiest way, it's the easiest thing, and it's actually the most advantageous. It's the simplest one and requires the least amount of effort. Okay, so if your plants can do C3 photosynthesis, there is a definite advantage to that. Okay, and it will do C3 photosynthesis. Okay, however, there's a big, huge problem with C3 photosynthesis. C3 photosynthesis really only works great when there is a lot of water and not a lot of heat. Okay, so it can't be too hot. Okay, so places like in the desert can't do C3 and stuff for reasons I'll explain later. But so they have to come up with alternative pathways. Okay, see, C3 plants do really well in cold, moist weather. C4 and C chem plants are adapted in drier, hotter weather. So actually, what the temperature difference is anything about 25 degrees on average. Chem4 and chem plants, or sorry, C4 and chem plants do better. Okay, anything below 25 degrees on average, C3 plants do better. Okay. So C3 plants are here. Okay, all the photosynthesis occurs right here in these cells. Okay, photosynthesis only takes place in the mesophyll cells right here. Okay, but during hot, dry weather, because the plant doesn't want to dry out, the stroma have to close, okay, to conserve water. If you close to conserve water, then what happens is one, CO2 can no longer get in, and most importantly, oxygen cannot get out. Okay, when oxygen builds up, okay, when oxygen levels build up, you get this process called photorespiration. Okay, photorespiration is burning through photosynthesis things without generating sugar. So you're screwing up photosynthesis. So it makes your photosynthesis very, very inefficient. Okay, so you're actually burning energy instead of making energy. Okay, so in C3 plants in hot, dry weather, instantly don't do well at all. Okay. Okay, so C4 plants. Okay, C4 plants have a very different structure. Okay, so oxygen comes in here. Okay, the light reactions occur here. The Calvin cycle occurs there, and it works better. Okay, that way you don't have cells that have a lot of oxygen and they're trying to use the Calvin cycle because that doesn't work. Okay, so oxygen is high in high levels in the mesophyll cells, but oxygen is in very low levels in the bundle sheath cells where the Calvin cycle happens. By separating the two stages, one in each cell, it separates the oxygen from photorespiration. So the way to understand this is C4 separates based on space. Okay. And two different locations. Okay. By separating the two steps in two different locations, I can move the Calvin cycle, the carbon cycle, into a cell that has very low oxygen levels, and that makes it work a lot better. Okay, while the light reactions occur in the cell, and that cell gets a lot of oxygen, but that's okay because the oxygen isn't poisoned by my Calvin cycle, okay, or my carbon cycles. Okay. Okay. CAM plants, okay, because it's called CAM because the very first thing they make is something called CAM. Okay. Calvin cycle, the CAM plants separate the two cycles based on time. Okay. Carbon cycle only occurs at like, okay. So the so all reactions for photosynthesis occurs in mesophyll cells, but it does it in two separate stages. Okay. Okay. So what happens is during the day when it's hot and there's a lot of light, it uses the light to build up, okay, the light reaction. So you build up a whole bunch of ATP and you build up a whole bunch of NADPH, okay, but you do not do anything in terms of the carbon the carbon cycle. Okay, okay, you hold the Calvin cycle steady, and at night, then you open up the pores, you release the oxygen, take in the carbon dioxide, and you do the Calvin cycle in the dark. Okay, that way there's very little oxygen inside the cells at that time. Okay. Yeah. I think that's it for this chapter. All right, I will see everybody in class.